This video is an introduction to stoichiometry calculations. And with stoichiometry, you always start with a balanced equation. So let's take a look at this reaction, the reaction of iron 2 nitrate with sodium phosphate. And you should recognize this as a precipitation reaction because it forms this solid product, iron 2 phosphate, and that's what we call the precipitate. So if you see a product formed that is a solid phase, generally that's going to be a precipitation reaction. And the other product is sodium nitrate. That's still soluble, it's aqueous, so that's a salt. And the first thing we want to do is make sure that this equation is balanced. You can see we have 3 iron atoms in the product on the right, so 3 in front of iron nitrate. And then you can also see we have 2 phosphate ions in iron 2 phosphate. So let's put a 2 in front of sodium phosphate. And then if you count up the sodium ions and the nitrate ions, there are 6 of each of those. So we have 6 sodium nitrate on the right. And so we can ask all kinds of questions now that this is balanced. Generally, the most common question that you'll see is how much product is formed. And the product of interest in a reaction like this is usually the precipitate. But you could also find out how much sodium nitrate is formed if you wanted to look at that. So let's say we start with 5 grams of iron nitrate. How much iron phosphate can we form? So the first thing you want to do is convert grams to moles. So 1 mole of iron nitrate has a mass of 179.86 grams. And so now we're in units of moles of iron nitrate. And this next step is the key step. So in this unit conversion factor, we call this the mole-to-mole ratio. And we're looking at the ratio of moles of iron nitrate. So we want to cancel that one out, and we want to end up units of moles of product. So we want moles of iron phosphate. And this is where we look to the balanced equation. So we look at the coefficients, the mole coefficients in front of each species in the balanced equation, and we put these into this mole-to-mole ratio. So we have a 3 in front of iron nitrate, so we have 3 moles of iron nitrate produces 1 mole. There's an invisible implied 1 in front of iron phosphate. So we have 1 mole of iron phosphate formed from 3 moles of iron nitrate. And then now that we're in moles of iron phosphate, we can multiply by its molar mass. So 1 mole of iron phosphate has a mass of 357.48 grams, and we end up with 3.31 grams of iron phosphate. That's the maximum amount of iron phosphate that we could form if all of that 5 grams of iron nitrate reacted. And we often refer to this as the theoretical yield. So that's the maximum amount of product we could form if all of the iron nitrate reacted and we were able to recover 100% of that iron phosphate formed. So we'll use the theoretical yield in percent yield calculations a little later. So another question we might ask is how much sodium phosphate is required to react with 5 grams of iron nitrate. So how much sodium phosphate is required to produce that much iron phosphate? So we start out the same way. We have 5 grams of our iron nitrate reactant. Let's convert that to moles again. 1 mole of iron nitrate has a mass of 179.86 grams. And now the second step, the key step here, is the mole-to-mole ratio. We want to cancel out moles of iron nitrate, but this time we want to end up in moles of sodium phosphate. We want to find out how much sodium phosphate is required to react with that much iron nitrate. So we want to end up in moles of sodium phosphate. And we looked at the balanced equation. We have a 3 in front of iron nitrate, and we have a 2 in front of sodium phosphate this time. And so now we're in units of moles of sodium phosphate, and it has a molar mass of 63.94 grams per mole. Okay, and that's our calculation. So we end up with 3.04 grams of sodium phosphate. And that's how much would be required to react with 5 grams of sodium nitrate.